So for my Lab 5, I decided to test Newton's second law when modeling a system of an object dropped from rest falling to the ground. I used Tracker to observe the motion and then did some modeling in VPython. My results were that the Newton's first law is accurate, but more so when drag is added into the mix. When it's just force of gravity, there it is not as accurate. So what I did was I was using this formula, the top one, to determine the velocity, and then using that velocity to determine the change in position. So F net up here, at first I modeled just as gravity times mass, and as you can see towards the end here, it starts going faster than the observed data and ends up in a position lower than where the observed data ends up. So I added drag into the mix to account for the air resistance, and after playing around with it a little bit, I got these results, which are much closer. As you can see, they end in the same spot. There is some discrepancy here, but for the most part it is pretty accurate, I would say. The curve is about the same, starts off the same, ends the same. As you can see, the velocity at the beginning is in all cases 0, and it slowly picks up speed, accelerating. If the ball were, instead of being dropped from rest, if the ball had been thrown down, this would be a lot faster in this direction. It would start off with a lot steeper curve down and would reach the end much quicker. If it were thrown up, we would see the position going up and then going back down as the force of gravity slowly takes over and has the ball fall to the ground. So I had to find the mass of this paper ball, and once I had that, I pretty much had all of the data that I needed to make my computational model in VPython. Here it is. Here is my drag. Right here I used this, I found this this constant after doing some experimenting with it, and I have this little equation right here. The ball speed squared times that constant gives me the drag, and the vector is just that in the y direction. And I have that added to W being the ball mass times gravity downward, and that is what got me my more accurate results. So basically what's happening here is the ball is being pulled by the Earth downward. The Earth is much larger than the ball, so the gravity causes it to fall towards it. And all in all, we found that Newton's second law is accurate. So I guess that's good, because if it wasn't, then we would have a lot of problems, given that a lot of our physics knowledge is based on Newton's second law. So hooray for Newton and his laws. The end.